Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 3, Rectangles Inscribed in Circles. Okay, so inscribed means that each vertex of the rectangle will be on the edge of the circle and the rectangle will be inside the circle. So here we go. Opening exercise, using only a compass and a straight edge. So there's my straight edge, here's my compass. Find the location of the center of the circle below. Follow the steps provided. It says to draw chord AB. So the first thing I'm going to do is put a dot anywhere on the circle. There's A. And I don't know, over here, right there, good. Here's B. Okay. So a chord is a line segment that goes from one point on the edge of a circle to, and each endpoint is on the edge of the circle. So if I drew a segment, now let's use a different color so I can see my dots. So now if I drew a segment, let's make it thin. There we go. Okay. And that there is a chord AB. Check. Construct a chord perpendicular to AB at endpoint B. So I want to draw another chord that's 90 degrees perpendicular to AB from the point B. Okay. Okay, so this one here, to draw a perpendicular from an endpoint, what you need to do is you need to extend the segment that you have. Let me use blue. Beyond that point, like so. Then you take your compass and I'm going to run out of room here. There we go, move that up. You put your compass point on that endpoint B. Let me move this. Okay, so you put your stylus there, it's called. Put your endpoint right on as accurately as possible. A little to the right, there we go, maybe. Okay, and you draw an arc right here. And then you go around to the other side and you draw an arc there. Okay, so there are the two arcs. Then what you need to do is put your stylus or point of your compass on that. Open your compass up and draw an arc up like so. Without changing the radius, go to the other endpoint. So really what we're doing is finding the midpoint of these two arc points that we made with that circle. And there is another point. X marks the spot, if you will. And you come down like so. And you put the ruler like so. Here, let me be totally accurate here. Let's put 0 on there and rotate accordingly. Draw a line segment down, and there is my perpendicular at B. I'm off just a little bit. Unfortunately, you can't do this on paper, but I can do it on mine. So it should actually be more like that. I might not have had the compass there, but I'm just showing you the process. Okay, so there it is. Construct a chord perpendicular to AB. So here's where it's supposed to be. So I'm going to extend that now. I'm going to extend that down because that's not a chord. That's outside the line or outside the circle. And so I'm going to extend this down like so to this point here. So that is perpendicular. Okay. And so now I have this point here. So construct a chord perpendicular to AB at endpoint B, which is right there. And that's done. Mark the point of intersection of the perpendicular chord and the circle as point C. AC is a diameter of the circle. Okay. All right, so push my ruler off too far, but I have to get another one. Good thing I have an unlimited supply of rulers. All right, so they're saying now that AC is a diameter. So I'm just going to show that. It's not going to be part of our rectangle, or is it? I will just do a dash line for right now in black. So here is, okay. Here is AC. All right, so if you draw a chord and then draw a perpendicular to that chord, then you are actually, no matter where you put that chord, you're going to create a diameter. So I know the center's on here somewhere. So we've just narrowed it down from any space around here or over here to this line here. And we just need to find the midpoint now. Remember what we're trying to do here. We're trying to find the center of the circle. So I now know the center's on this, and it is the midpoint of AC. So AC is the diameter of the circle. Construct a second diameter in the same way. And what they mean by that is now I'm going to draw another perpendicular from A down. So if I put so I have to extend my green chord again. So if I put this back, line it up as good as I can, as accurately as I can. And this is my extension of AB. And then I take my compass and I put it at A. I'm trying to be really accurate here. Okay, I'll close it up a little, rotate it around, and remember how to do this. We're going to just put a little arc here. And so I don't have a whole bunch of circles, come around here and draw a little arc there. So that would be a circle. So this is a radius and that's a radius. So they're equidistant from A. So A is the midpoint of this segment from these arc to arc. If this was a segment, A is the midpoint. So now I'm going to open this up a little bit. I'm going to rotate it up here and draw an arc from center at that endpoint. And then I'm going to move my compass to this end and rotate it around and draw an arc there. So where the two arcs intersect is my point. That would be draw the perpendicular line down through A. So now I'm going to do that. So I put my 0, line it up with here. So I'm drawing a line segment through this arc here, through A, and continuing down until I get to the edge of the arc. So let's call that point right here D. Okay, and now I'm going to connect. Trying to rotate this. I'm going to connect DB, and I'll use a dash line again. And when I do that, I drew another diameter. And where the two diameters meet will be the midpoint. Because if I connected DC now, like so, okay, this looks a little bit off, but you get the idea. That should be a rectangle. Okay, so there is the center of our circle. Explain why the steps of this construction work. Okay, let me bring that explanation in. Okay, the reason is the center is equidistant from all points on the circle. Since the diameter goes through the center, the intersection of any two diameters is going to be a point on both diameters and must be the center. So I did this with a rectangle. I could have chosen two different points and created another, but anyhow, it doesn't matter how you do it. All right, exploratory challenge. Construct a rectangle such that 4 vertices of the rectangle lie on the circle below. All right, so now that we've done that, you should be able to do this. So pause the video, see if you can do this, and then come back and check. So the first thing we're going to do is put a point on the circle and call it A. Okay, the first side's easy. I'm just going to construct a chord. So I'm going to go a little shorter on this one. I'm going to go out here and draw a segment like so. So there's the other end here. So there is my chord AB. I then extend AB beyond. I'll use a different color. I'm going to extend AB beyond. Then I'm going to get my compass. And I'm going to put it on B. You could put it on A, it doesn't matter. But we put this on B, and let's use green. And I don't need it real long. Cross there, rotate around, intersect the black line segment. So these two endpoints, this is the midpoint of those two arcs I just created. So then I put my stylus on that arc and rotate up. Need to open the compass more than halfway. So my arc is up here somewhere. Move that to B. Rotate. And rotate this. And draw a line segment through. And that would give me a perpendicular line. So I'll do that in black. Like so. So there are two sides of my rectangle. So there's AB, there's BC, and then I can continue by putting this back here, and I'll use all my extensions as red. So I'll extend this out like so, switch to green, put my compass on C, close it a little bit, draw an arc, come around to the other side, draw an arc, and then move the stylus to one of the ends, one of the arcs, open it up a little further, bring it up here, make an arc, move the stylus to the other end point of where C is the midpoint, and draw an arc, rotate my ruler, and I'm going to draw a segment perpendicular to here, going through this way. So then I go out to there, and this point right here is D. And I should make this black because I'm doing all of my sides in black. Okay, and then all we have to do now is connect AD. And if you notice when you're doing a construction, if you're just off a couple of degrees, it will not look perpendicular. Okay, so that's pretty close there. There is a rectangle. So these should all be 90 degrees because of my construction of a perpendicular segment going through the endpoint. Okay. Okay, page 2, exercise 1 says to construct a kite in the circle below and explain the construction using symmetry. Keep in mind that a kite is a quadrilateral where it has two congruent long legs and two congruent shorter legs. And so in other words, you got a short leg, long leg, long leg. This is congruent to this. This is congruent to this. And if I draw a segment like so, the longer diagonal bisects the shorter. Okay, so think of this long line here as our diameter in this circle. So if I construct a triangle with the diameter being the hypotenuse and reflect it across that, we will create a kite. And that's our idea. So that was just my little rough thinking through this. So in other words, I'm just going to put a point, say here, and call it A. And I'm going to put B at 12 o'clock. That's where my first segment's going to be, AB, so that my perpendicular, my diameter is actually vertical. And that's my goal here, just to make it neater. All right, so now I'm going to construct a segment using a ruler, okay? But you get the idea as to how to use a ruler. So just pretend I'm using a ruler, but I'm going to use my segment just to save time. So now I want to draw a line segment from A to B, like so. All right. So it's just easier for me to do this in a video. So there's my segment AB. So pretend I used my ruler. All right, so then what do I do? Well, remember we want to find the diameter, and how did we do that last time? We drew a perpendicular to AB. All right, and in order to draw a perpendicular, I would then just have to extend this outside beyond like so. Okay, so now I have the endpoint at A and then going through B like that. All right, and then I get my compass and I put it on A. Let me rotate it so I don't lose that. Put it on A. Actually, let's do it on B. So B will be my midpoint. And I'm going to open it up just a little. That should be good right there. Let's change the color to red. And I'm going to make an arc. And then I'm going to bring it around. Okay. I can't rotate it now because it's off screen, unfortunately. Maybe I better do it this way. So here's an arc here. And if I go all the way around, now it's out there. So let me delete that first one. So I created a new circle. There it is. So this is an endpoint, and this is an endpoint of a segment where B is the midpoint. And then we're going to put this on an endpoint, not B, you just did that. Put that on an endpoint like so. Let's open it up a little further and draw an arc. Bring it over to this endpoint of that segment we created with the two arcs and draw another arc. So there are my two arcs where they intersect, and then I would draw a line segment with my ruler, but I'm going to just do a shortcut here. Pretend I'm using my ruler, make it thin, starting at this intersection going through B so that it's perpendicular. Okay, so it's off just a little from my construction, but this kind of looks perpendicular right there. So in other words, we just constructed a perpendicular and then we found where it intersects. Okay, so actually I did this backwards. I should have done it at the other end if I wanted this to be my diameter, but that's okay. I'm just going to keep going here. So now AC is going to be my diameter. So then I'm going to construct a segment. Again, you would use a ruler. I'm saving time with my program. You construct a segment AC like so, and there is my triangle, and it is a right triangle because that's 90 degrees right here. Okay. And now I need to reflect this across. Well, how am I going to reflect that? Let me get my compass. I'm going to put my compass, whoops, what is going on here? I'm going to put my compass at A. And I'm going to draw a circle. Because if I draw a circle with center A, radius AB, okay, like so. And I draw a circle, let's make it a little bit wider. That's the problem with an electronic compass. You can't get small increments in between. Come on, cooperate. Okay, so say this is going through B right here. If I draw a circle, that is a circle with radius AB. So if I drew a line over to here, this would be the same, AC would be the same length as AB because it's the radius of this green circle. So then I'm going to construct a line segment. Again, I'm going to use my program instead of the ruler. And there's my segment AD, if you will. So I'm going to name that D. Okay, move this out of the way. So now you can see that this side would be congruent to this side. And now I just need to connect C and D, and we have our kite. Again, assuming that I'm using my ruler here, I would take a line segment after lining up the ruler with C and D like so. I would draw this here. All right, so there we have it. So it doesn't look very neat because of all the construction marks, but if I were to clean up the construction site after my work is done and get rid of all of these arcs, but not our background, that would be a bad thing. Okay, and there's a little green arc there. And then if I just shorten this up to here and shorten this down to B and shorten this down to B, this is what our construction would look like. So there is a kite. By definition, a kite has two right angles. This segment's congruent to this segment's congruent to this segment, and these are 90-degree angles. So there is a kite inscribed within a circle. Okay, number 2, given a circle and a rectangle, as in this photo right here, what must be true about the rectangle for it to be possible to inscribe a congruent copy of it in the circle? So given a circle and a rectangle, what must be true about the rectangle for it to be possible to inscribe? So what they're basically saying is if I have a circle like so, all right, and I have a rectangle like so, what must be true about this rectangle for it to be inscribed, to inscribe a congruent copy of the circle, of it in the circle? So how would I copy that so that it would fit inside the circle? Notice this rectangle is too long. These two endpoints go beyond the circle. And if I made the rectangle smaller, and then I bring it over and line it up, put these 2 points on the edge of the circle like so, now it's too small. So what this question is saying is, what must be true about the rectangle for it to be a possible inscribe of a congruent copy of it in the circle? Okay. All right, so we kind of answered that question on the last page. So let's go back. So it's right here. This is a rectangle, it just doesn't appear to be one. It doesn't look quite perfect. I would have to rotate some stuff around just a little bit to make AB parallel to CD. I was just off a little, and you get the idea. But anyway, this is it. Pretend this is a rectangle. Well, what has to be true? The two diagonals have to go through the center of the circle, and the two diagonals must be diameter lengths. Okay, so that's the answer to that. In order for this rectangle to be inscribed in this circle, the distance from here to here must be the diameter. And obviously this is not a diameter because it won't reach. Okay, so the diagonals of the rectangle must be the length of the diameter of the circle. All right. So let me do that real quick. So I'm going to put a dot there because I didn't have a center before. So if I put a dot right there, and then I choose my circle program or my circle tool, instead of using a compass, this makes a really nice circle like so. And then I take my segment and create it, and let's make it thinner. So it's going through that center, like so. There is a diameter of a circle. And then if I take that diameter, come on, if I take this diameter and put this rectangle here and extend the rectangle out so that it goes to this end like so, like that. So let me make this thinner and let's make it blue. Okay, so what I'm saying is now that that diagonal is the length of the, that diagonal is the diameter, then when I put this in the circle, it is inscribed and the corners are on the edge of the circle. Okay, the figure below shows a rectangle inscribed in a circle. So there it is, just like this. The figure below shows a rectangle. List the properties of a rectangle. Okay, opposite sides are parallel and congruent. We have 4 right angles, and diagonals are congruent and bisect each other. That is everything we know about the properties of a triangle. Okay, page 3 brings us to part B. So I copied the diagram over from the previous page because this is what we're talking about. And it says list all the symmetries in this diagram that this diagram possesses. Okay, so here it is. Opposite sides are congruent. Okay, so this side's congruent. So let's label this up. So let's, this side is congruent to this side. And let me just switch pages back and forth because my pen whacked. This side is congruent to this side. So opposite sides are congruent. All 4 angles are congruent because they're all 90 degrees. Diagonals are congruent. Okay, those are the same length. The figure may be reflected onto itself across the perpendicular bisector of the sides of the rectangle. So in other words, if I drew, what would a perpendicular bisector look like in this situation? What they're talking about is, let's do green and dashed. This would be a perpendicular bisector roughly from the short sides. And if this was the midpoint and this was the midpoint and that was perpendicular, then we could reflect this across either of those 2 lines. Okay. And the figure may be rotated onto itself with either a 180 degree rotation or a full 360 degree rotation. Okay. What are the properties of a square? Okay, so for starters, I'm going to draw a square. I'm going to do it real quickly with this tool here. So there's a square. All right, so list the properties of a square. All righty, so first things first, all sides, whoops, thought I chose this, hello. All sides are congruent. All angles are congruent and 90 degrees. What happens if I draw a diagonal? Or draw diagonals. The diagonals are congruent, but in this case, they bisect each other as well. Same as the rectangle. And the diagonals are perpendicular in this case. So let's see if we covered everything. Opposite sides are, oh, I didn't say anything about parallelism. My fault. Opposite sides are parallel. Okay, all sides are congruent, got that. 4 right angles, got that. Diagonals are congruent, said that. Bisect each other, said that. And are perpendicular, said that. So I forgot to mention that opposite sides were also parallel. Okay, so there we go. Now it says list the symmetries of the diagram of a square inscribed in a circle. So now if I take that, first thing I'm going to do is I'm going to draw it. So let's put a dot for my center, like so. And then I'm going to draw a circle from that center, like so. And now if I were to draw a diagonal, let's make it red, or not a diagonal, but a diameter. Let's make it thinner so I can see my dot. Okay, so there's a diameter. Now, if I were to do a perpendicular bisector, so I'm just going to do this real quick, and let's make the ink green. If I were to put my compass on this point A, if we will, I haven't named them yet, but if I were to, it would probably be A. Let's rotate this around, open this up beyond halfway, and notice my compass is not on the end. Okay, rotate and draw an arc. And then bring it down here and draw an arc. Okay, and then go to the other end, put it on this segment end, draw an arc. I could just continue, and I guess I will, and draw another arc. Okay, so then when I get my ruler, I'll use a ruler this time, and I line up my arcs, then this segment that I draw going through those like so, hello. All right, let's get this out of the way. Let's erase this, all my construction marks. So what I just did was I drew diagonals, and now if I just connect my diameter endpoints like so, and it's snapping here, so this isn't going to be perfect. But this is how you would construct a square. Okay. And unfortunately in this program there, that's not too bad right there. There we go. There's my square. See, it's snapping to perpendicular. Vertical. Okay, so anywho, it looked better over here. It won't quit snapping. See how it snaps there? I can't quite get it in between, but you get the idea. Okay, so there's a square. List all the symmetries of the diagram of a square inscribed in a circle. Okay. Here we go. Just to save time, I pulled it from the other page, and here we have all the symmetries. So in addition to the symmetries listed in B, all four sides are congruent. The figure may be reflected onto itself across the diagonals of the square, and the figure may be rotated onto itself with either a 90 or a 270-degree rotation, either clockwise or counterclockwise. So not just 180 and 360, but 90 and 270 as well. Okay, number 4, a rectangle is inscribed into a circle. The rectangle is cut along one of the diagonals and reflected across that diagonal to form a kite. Draw the kite and its diagonals. Find all the angles in this new diagram, given the acute angle. So first thing we need is a circle. And in order to draw a circle, I need a center. So I will put a center right there. Okay, actually, let me do it a different way. Let me pick a circle and hello. What's going on? me try using my pen. Experiencing operator difficulties, please stand by. Okay, that's not working. So I guess I do have to put a dot. I can't do a little circle to be my center. So if I put a dot right there, and then I choose my circle, and if I had a compass, I would just put my compass there and draw an arc. So I'm going to make this kind of large. So there's my circle centered right there. A rectangle is inscribed into a circle. Okay, I'm not going to construct another one. We've done that in this lesson. I'm just going to create a rectangle. So I will pick rectangle and draw a rectangle just using my program so that it fits inside the circle. Okay, like so, and then just shift it down just a little bit. There we have it. So let me mark the points here. A. Let this be B. Here is C. Here is D. A rectangle is inscribed into a circle. Check. The rectangle is cut along one of the diagonals. So now I'm going to draw a diagonal from A to C. Okay, so what they're saying is cut this. So now I'm just going to trace. That's the joy of doing this with a program. So make this red. So let's make it green. And I'm going to draw it from here to B. And I'm just tracing this because I'm going to get rid of my rectangle in a minute. Okay, and then do it again. From here down to there. And then I'm going to delete my rectangle. So there's my half rectangle. And what they're saying to do is reflect this across the diameter or the diagonal of the rectangle, and it will form a kite. So in order to do that, I will use my compass. Put the compass at B. Open it up a distance to C. So what I'm really doing here is forming a radius of BC, a circle with a radius C. I'll draw it in red. That's off just a little. Let's put it on B, not next to B. Right there looks good. Open this just a hair more. There we go. And there is a circle with radius BC, but actually I should have my point down here now, but it doesn't matter. I set it up. And this arc right here should go through B, as it does, as you can see. So this is a circle centered at C with radius BC. So therefore, I now have this point over here, and let's call it E. And then I can finish my kite. So I will now draw a segment, make it green like the others, make it not quite so thick. And I'm going to draw a segment from C to E, and then from E over to A. All right, so there is my kite. Get rid of my circle, not my background. Get rid of my circle, and there it is. And D was where my rectangle was. There's the diagonal. Reflect part of the rectangle. Half the rectangle got reflected over the diagonal. Okay, so that's what they asked us to do. Draw the kite in its diagonals. Okay, so that first diagonal was already drawn. So the long diagonal was our diagonal of our rectangle originally. And now I just need to draw the BE segment. So choose line segment, segment, dashed, not so thick, and let's do blue again, and we're going to draw a segment from B to E. So there's my kite. Find all the angles in the new diagram, given that the acute angle formed by the diagonal of the rectangle of the original diagram was 40 degrees. Okay, so let's use purple. So let's reread that. So remember, this whole thing was 90 degrees because it was a rectangle. And then it says, given that the acute angle formed by the diagonal of the rectangle in the original diagram was 40 degrees. So they're talking about this angle here, angle BAC is 40 degrees. So if I still had my rectangle, it would have been here. This was 90, so this is 40, and this would be 50. Okay? It doesn't look like it's 40, but it all depends on the size of your circle, how many degrees that will be when you do this. Okay, so here's 40 degrees. So if that's the case, and this is 90, the triangle sum theorem is going to force this angle here to be 50 degrees. Okay, and then we have a right triangle here, so this is 90. So this angle here would be 40 because of the triangle sum theorem. And this angle here would be 40 degrees, and this angle here would be 50 degrees. So our angle here is also 90 degrees because it is a reflection of a rectangle, and that was 90. And so this angle here is also going to be 40 degrees because this bisects the kite. And this angle up here is 50 degrees. So the total up here is 100. The total down here is 80 and 90 and 90. So we had 100 degrees. So angle ECB, the measure of angle ECB. Thought I waited long enough so that 100 would move. The measure of angle ECB equals, so here's ECB, that's at 50 plus 50, or 100 degrees. The measure of angle BAE equals 80 degrees. The measure of angle ABC equals 90 degrees. And the measure of angle AEC equals 90 degrees. So 90 plus 90 is 180. 100 plus 80 is 180. 180 plus 180 is a total of 360 degrees. And all quadrilaterals angle sums are 360 degrees. So there we have it. Okay, page 4, number 5, challenge. Is it really that much of a challenge? We'll see. Show that the 3 vertices of a right triangle, so here's a right triangle. How do we know it's a right triangle? Well, let's see. Show that the 3 vertices of a right triangle are equidistant from the midpoint of the hypotenuse by showing that the perpendicular bisector of the legs passes through the midpoint of the hypotenuse. A, draw the perpendicular bisectors of AB and AC. Okay, let's do that. So I'm going to get my compass, and how do we do perpendicular bisectors? We put our stylus on one end, like so, and we rotate it, and we open it out more than halfway, like so. And now I just need to adjust this. The electronic compass is not the best. So I'm going to rotate up here, draw an arc. Okay, bring it down to the other side, draw an arc. Move the compass to A. And rotate it, draw an arc. Unfortunately, I'm going to have to draw, I'm going to have to draw a longer arc. I'll just go like this because I couldn't grab that to rotate it. So there we go. So our points of intersection are here and here. And here I would use a ruler to connect, but instead I'm going to use a segment like so. Segment, thinner, and let's use red. Starting right at that point and going to this one. So there is my perpendicular bisector. And so this point is halfway between A and B. All right, so I drew that perpendicular bisector. Now it says to draw a perpendicular bisector to AC. So let's use blue this time, just so I know my arcs. And put that right on C. Draw an arc. I guess you could just go all the way around over to the other side. Move this up to A. And draw an arc. Construct a segment, and I'll use red again. From my intersections of my two blue arcs, which are right here, that's why it's a good idea to use different colors if you can, and go to this end. Okay, I'm off just a little. When I let go, it moved. All right, so there we go. So here is the other perpendicular bisector. So as you can see, we're close. It's not exact, but this point right here where they intersect should be right about here. That is the midpoint of the hypotenuse. So show that the three vertices of a right triangle are equidistant from the midpoint of the hypotenuse. Okay. A, draw a perpendicular bisector AB, that's this one here, and AC, that's this one here. Label the points where they meet P. So this was the point P. What is point P? It's the center of the circle. C, what can be said about the distance from P to each vertex? Well, from P to C is a radius. From P to B is a radius. If I drew a segment from P over to A, it would be a radius. So the distance from P to any vertex in the triangle are equal because they are radii. So point P is equidistant from those three vertices of the triangle AB and C, so the circle is circumscribed about triangle ABC. Okay, so that's also, since they're all radii, we will know that it is circumscribed. D says to repeat this process, this time sliding B to another place on the circle and calling it B prime. Okay. Okay, so I just got rid of all my construction points here, so here we go. I did leave the perpendicular bisectors though. So now I'm going to move B somewhere else. It doesn't say where, it just says anywhere else. This time slide B to another place on the circle and call it B prime. So I'm going to put B, I don't know, right here, and I'm going to call it B prime. So now we are going to have a circle. And now we want triangle A, B prime, C is what they're saying. So see right down there, A, B prime, C. So now I need to draw segments. So let's do that. And I'll make them purple. So now my triangle is going to go from A to B prime instead of A to B. And then B prime is going to go to C. So now this is the triangle we're talking about. Okay, so I just moved the triangle that we had, shifting B prime down here. So now what do we do? Well, what did we do up here? We did a bisector of AB, so now we're going to do a bisector of AB prime. So in order to do that, I put my compass at A, open it wider than halfway, and draw an arc. Move it to B, and repeat. Where those 2 points intersect will give me a bisector, perpendicular bisector. So I will do that in orange. And that will go from this point here, if I were to use a ruler, to this point here. Notice it's going through P as well. Let's make that a little thinner. Okay, So there is my perpendicular bisector of AB prime. And now I'm going to do the same with AC. Well, AC is already done, so I don't need to do it again. And as you can see, the orange segment went through my perpendicular bisector of AC, which is this one. So if I change that color to brown or whatever, then you see that it also intersects this orange line at P. So what do you notice? Still centered at P. So you get the same center. So no matter where you move this, wherever the triangle is, as long as all 3 points are on the circle, in other words, as long as the triangle's inscribed in the circle, then the perpendicular bisectors of the sides of the triangle will intersect at the center of the circle. Is there a relationship between the measure of angle ABC, which is right here, and AB prime C? Is there a relationship? Here's what we say. Okay, so as long as B and B prime are on the same side of AC, okay, in other words, I couldn't move B prime in between them, then angle ABC and AB prime C have the same measure because they are inscribed in the same arc. If B and B prime are not on the same side of AC, then the measure of angle ABC would not equal the measure of angle AB prime C. So what they're saying is B prime could be here. And then if I draw a segment from here to here and here to here, then now B prime is obtuse, therefore not equal to B prime or B here. B is acute, this is obtuse. It obviously can't be congruent anymore, okay? Because they're not inscribed in the same arc. Okay, the arc being A, B, C. It's called a major arc if it's larger than the other arc forming the circle, the major arc. Okay, page 5 brings us to the end of lesson 3. Review the lesson summary and go to your problem set.